Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and talk about an important topic about how to handle Java exceptions in C++. So there are two topics here. One, how to handle Java exceptions. For example, if we are writing some Jni code in C++ and let's say we call a Java method of an object and that method can throw an exception. The question is, how do we detect that an exception was thrown in Java when we are writing a Jni code in C++? And then the other question is how to handle it, right? So how to detect and handle, and then how to actually throw a new exception in C++ when we are writing Jni code, right? So Java puts a strong emphasis on exceptions and exception handling. Obviously, we have two types of exceptions in Java: checked exceptions and unchecked exception or runtime exceptions. Checked exceptions, the compiler ensures that the programmer handles the exception somehow or eventually throws it out of the main, which is not recommended. So if there is a checked exception like IO exception, the programmer must handle it at some point through the call hierarchy of, let's say, a method that throws that exception. Certain Jni functions use the Java exception mechanism to report error conditions. Jni functions report error conditions by returning an error code and throwing a Java exception. All right, so an error code can be returned from the Jni functions that deal with exceptions. The error code is usually a special return value, such as null, that is outside the range of normal return values. So if you want to create a Java object using a Jni function, and if the return type is null, we can say that, okay, some error happened, which is most likely the out of memory error, because when JVM cannot allocate memory, it throws the out of memory error, right? So out of memory error, out of memory exception, and then the return type that we get in C++ from the Jni function that creates new objects has a null value, right? Because that tells the programmer that, hey, there was an error occurred and JVM couldn't actually allocate the memory for creating this object, right? There are two cases where the programmer needs to check for exceptions without being able to first check an error code. The Jni functions that invoke a Java method return the result of the Java method, right? So if a method, we call a method in an object using a Jni in C++, and obviously that method can return a value or throw an exception, right? In this case, we can call the exception occurred to check for possible exceptions that occurred during the execution of Java method. Actually, there's another method. So this exception occurred gives us a J-throwable object, an object of that corresponds to the exception types, and then if it's not null, we can assume that an exception occurred. But JVM or Jni has another method called the exception check that returns a boolean value, a J boolean value, and we can actually check if the result of calling a method in Java was the throw of an exception, right? So we can either check the object here to see if it's null or not, or we can call the exception check function to see if an exception was actually thrown. Some of the Jni array access functions do not return an error code, but may throw an array out of bound exception or array store exception. Now, array index out of bound exception is very easy to understand what it does, what it means, right? If an array has 5 elements and we try to access the 6th one, it throws an exception. Array store exception is when, let's say, we define an array of objects, right? And then we try to write a string to it, and then we try to retrieve them as, for example, integers or some other type of object. Then it says array store exception. In all other cases, a non-error return value guarantees that no exceptions have been thrown. Alright, there are two ways to handle an exception in native code. So again, we first look at how to handle exceptions that might happen or might occur in Java, and then next we look at how to actually throw new exceptions in C++, right? There are two ways to handle exceptions in native code. The native method can choose to return immediately, causing the exception to be thrown in the Java code that initiated the native method call, right? So we can choose to immediately return from the native method into Java, right? The native code can clear the exception by calling exception clear and then execute its own exception handling code. So again, in Java, we have the mechanism of try catch, and in C++ for Jni, we cannot use the try catch mechanism of the C++ itself because it's not compatible with Java try catch. So again, instead we use Jni Functions. So if we want to basically handle an exception, first we check if an exception occurred. Basically we check the exception, so basically exception check. So we call a method from Java, and then we call this Jni function exception check to see if an exception was occurred or not. If it's occurred, then this is like this if statement, and then the body of the if is like the catch part that we write in Java, right? Because once the exception occurred, we can write some code to handle that exception. But first, we need to tell the JVM that we actually want to clear that exception. Otherwise, the native call will immediately return, right? So once we check the exception, and if an exception occurs, we can, in the body of the if, we can call the exception clear to tell the JVM that, hey, we are handling it, don't worry about it. When you go back to Java, don't panic, don't freak out, and don't go into the stack unwinding. All right, just continue as usual. If we don't tell JVM that we are clearing the exception, as soon as JVM returns back from the native call into Java, it freaks out and it panics, and then it immediately goes out of the method, the Java method, and it starts stack unwinding, right? So exception clear is just a mechanism of telling JVM that don't freak out when you go back to Java. We handle the exception. Exception describe, this is just the stack trace, right? In Java, we can catch exception and say exception.print stack trace. In C++, we just say JVM describe the exception, and it prints the exception, basically the stack trace on the Java console, right? So this is not exception described is not really that much about handling the exception. It's just printing the stack trace on the console. An exception occurred. This gives us an object handler, a JThrowable, and then and this gives us a reference, basically a pointer to the Java object, and we can, because all the exceptions in Java are derived from the throwable object, then we can call any method on this throwable that is already inside the throwable class in Java, right? So the native code can either immediately return if we don't clear the exception, or we can clear the exception and then add some code that is equivalent to handling that exception. So in Java, inside the body of the catch block, we can write a code that handles the exception. In C++, again, we check for the exception if any exception occurred, and then we can first clear the exception and then write some code that is equivalent to handling that exception. After an exception has been raised, the native code must first clear the exception before making other Jni calls. So this must is important. We have to must, otherwise the JVM immediately returns from the native call, and then it panics, right? It panics and it freaks out. If we tell the JVM that we cleared it in C++, clear the exception, then everything goes as usual, nothing bad happens. So the native code must first clear the exception before making other Jni calls. When there is a pending exception, which means when an exception was actually occurred, the Jni functions that are safe to call are these ones. Now obviously we have two functions, Jni functions that are directly related to the checking or handling the exceptions, right? Check or handling exceptions. Exception occurred gives us a JThrowable pointer, JThrowable object that is the actual object of the type throwable in Java. Exception describe is just prints the stack trace on the console. It doesn't do anything. Exception clear is we're telling the JVM that, hey, we handled the exception, don't worry about it. Exception check returns a JBoolean and basically tells us if an exception was actually occurred, right? Now, if an exception occurred, we might be holding to some resources like string characters that were on the Java heap, UTF-chars, string critical. If you recall, when we talked about the getting critical access to strings, basically a direct pointer to the string, not to a copy. Release array elements, integer, double float, and primitive array critical. We have looked at this before, and again, critical access means it gives us a direct pointer. And so all the releases are safe to call. That's just because otherwise we might JVM will run into problems. So we have to, even if an exception occurs, and even if we want to directly return from the native call, we are still safe to call any of these methods to clean up any resources that we are, or release any resources that we are holding on to, right? And there are also other less known functions that are related to garbage collection. These are delete local ref, delete global ref, delete weak global ref. These are not that much important of what these are. We don't typically use them unless we want to really go into some advanced details of Jni. So there are functions. So there are three categories of functions that are safe to call if an exception is pending, or basically if an exception was occurred. One is checking and handling the exception. These are the ones that are most important. Trying to release any resources, any Java resources that we are holding on to, right? Memory resources, and then the garbage collection stuff. So check for exception with exception check. This returns a J boolean, which is compatible with the C++ boolean, so we can put it in the if condition. Handle the exception with exception clear. This tells the JVM that we handled it, don't worry about it. Print the stack trace with exception describe. So this prints the Java stack trace, right? And get exception object with exception occurred, right? And once we get this pointer to the JThrowable object, we can use two other methods or functions that Jni provides. One is throw. So we can actually get this exception object and throw it again. Just like in a catch block, we can throw the exception again. Or throw new. This is another that is not related to this exception object, but this is another function in JVM that allows us to actually throw Java objects in C++ in native code, which we'll look at it later, right? All right, so here's an example. Let's assume I write this person class, person.java. It has a constructor that takes a string name and integer age and throws IO exception, right? So here in the construct, remember that constructors can also throw exceptions. It's just not the methods, right? Constructors can also throw exceptions. And here I'm checking if the age is less than or equal to 0. If it is, I'm throwing a new IO exception and saying that age cannot be 0 or negative. Now, obviously, normally we won't throw an IO exception for this kind of errors. We throw something like illegal argument exception. But the reason I chose IO exception as an example here is because IO exception is a checked exception. So the compiler has to force us to handle it somehow, right? But then in another class, I write a method create person. It's a static native method. Create person, we send a string name and int age, and this returns a person. And because it's a native, actually the compiler doesn't force us to handle the exception in Java, right? So we don't need to add a declaration here that this method create person can throw any exceptions, right? However, if this was not a native, then I have to provide a body for this static method, and inside of that, at some point, I have to call the new person. And once we call the new person, because this constructor, this call to new, the constructor can throw a checked exception, the compiler will force us to handle that exception. So I just wanted to show you that if you for example, try to call this constructor or construct a person object using a native method, the compiler doesn't force you to handle any possible checked exceptions that the constructor might occur, right? Because call to the new person happens in C++, not in Java. However, if this was not native, then we have to provide a body for this create person, and because inside that body, eventually we need to call the new person, right? Explicitly we need to call it in Java, and then the Java compiler forces us to handle the exception, right? So handling the Java exception in C++, Let's say I create a J object person object and ask JVM to create new object. We have seen this before in the lecture that we discussed how to create Java objects in C++. We need to pass the J class meta information so that JVM knows which class we are talking about, and then the ID of the constructor, because constructor is just a special method, so we have to give it the JVM the method ID to call, and then the parameters of the constructor, which is a J string name and then the integer or JInt age, right? So I call the constructor and ask JVM to create a new object for me. Then I can check if an exception was occurred. So if exception was not occurred, I just print to the console successfully create person and object in C++ and then return my person object. Else, so basically this else part is like the try block that we write in Java, right? If everything goes well, we just return the object that we created. Otherwise, this if block is like the block that we write in the catch block inside the Java code, right? So if the exception occurred, we go into the catch mode, right? We try to handle the exception. So if Jvm Exception Check, so we ask JVM to check an exception was occurred or not. If this returns a boolean true, then this is the code that we can write to handle the exception. So exception describe is just prints the stack trace. It doesn't do anything else, right? Just like in Java, we can say exception dot print stack trace, right? It just prints them to the console. And then I'm printing something to the console, Java exception occur in C++. So if this exception check returns true, we know that some Java exception occurred. And then I want to tell JVM that, hey, I'm writing some code here that handling the exception, so don't worry about it. So I say JVM exception clear. So clear that exception, don't worry about it. And then let's say, then I return a default object or an object that has a default name and a default age, for example. This is how I'm handling this exception, by returning a default object. So it has a name Bob and age 21, right? So if something goes wrong in the construction of this object, which is the condition here is that if somehow age is negative, then we go into the exception throwing mode and then we go inside this block, right? Now another thing that I could do is that basically I could choose not to handle the exception. Then as soon as the JVM returns to the Java code, then it doesn't execute the rest of the codes inside the Java function, and it starts going out of that function and starts doing the stack unbinding. So let's go to Eclipse and try to look at this example. So here in person class, I have a string name int age, and then public person, the constructor, I'm saying that it throws an exception, IO exception if age is negative, and then I also have another public method print info. And if age is more than 100, then it throws an illegal argument exception, just as an example, and saying that, okay, this person is probably dead. So and then in the test exception in Java, I'm loading the dynamic library because I have a native method here in this class that creates a person for me. I send the Java string and Java integer to C++, and it's supposed to return back a person object for me. And in test 1, I'm trying to construct the person Bob, create person with the name Bob and age -1, and this is supposed to throws exception. So I already know that an exception will be thrown because age is negative. And then bob.printinfo, and the reason I have this call because we want to see the behavior for the first case when we handle the exception in C++, and the second case when we don't handle the exception in C++, right? I want to see what happens. So we don't handle the exception in C++. Now what we expect to happen is that if we don't handle the exception, when JVM comes back from the native code to this line of code because an exception was thrown, JVM freaks out and jumps out of this method and goes to main, and then if there is no code to handle it, and then just throws it out of the main and terminates, right? So this line of code, we expect that it's not going to be executed. On the other hand, if we handle the exception in C++, once we come back, and the way I'm going to handle it, just return a default object with a default name Bob and age 21. And then everything, JVM doesn't freak out and everything goes back to normal, and JVM starts to execute in the next lines of code. So when I handle the exception, I expect to see that this line of code gets executed in Java and the program terminates normally. All right. So we have this class that has a native method, so we have to select it, test exception, run our Java H tool, and it creates the header file. So test35 underscore test exception, and then Java underscore package name, class name, and method name, which is a create person. It's a static method, so we get a J class reference, not a J object. That's because it's a static method, and it returns a J object. And in the C++ implementation, I'm getting the person class metadata, the J class, JVM find class on the class path, and it's inside the test35 package in the person class, right? So this is the class path description of the person class, and remember that the class path separator is / in C++ inside the JVM. And then we need to create a person, so we have to call its constructor, and constructor is just a special method, so we need to get the J method ID, JVM get method ID, the J class, which is a person class, the name of the method, which is always init inside the diamond brackets. This is the signature or the name of the constructor inside the JVM, and its signature. So the signature of a method, it's its parameter signature, and then the return type. And for a constructor, we've said this many times, the return type is always void. And in this case, the constructor takes a Java string, L semicolon, Java /lang string, and also an integer. And the return type of the constructor is always void. Then I create this person object by calling the JVM new object, person class, constructor ID, and the parameters for the constructor, which is a J string and J int. But then I check if an exception was occurred or not. So if it's not, then we just successfully create the person and we return, right? And then let's maybe try to check this first. So let's set the age to positive number, and let's also build this C++ dynamic library. So it's finished. Let's copy and paste the dynamic library. All right, so right now this code doesn't throw any exceptions, so it has to basically it has to execute normally. So we successfully created person object in C++ because there was no error here, no exception. And then we call the print info, and it says the name is Bob and age is 15. So also no exception here. So no exception here, no exception here. If I set this to 150, there is no exception in the constructor, but this print info throws an exception. So successfully create person object in C++, but then an illegal argument exception was occurred in Java, right? So we could put it in try catch and try to handle it. But as the first example, we can create the object successfully in C++, and also we can call this method successfully. So the second case is when something goes wrong with the creation of this object, right? And in the CPP code, so if we check if an exception was occurred, so JVM exception check, this returns a J boolean, right? And it's compatible with the boolean type, so we can put it inside the if. So we check for exception, and then let's say I don't want to print a stack trace, that's fine. stdcl, I'm printing some message to the console, Java exception occurred in C++, but then I don't want to handle it, right? Exception clear, I'm not going to call it first, so let's comment it out. But then I want to return with a default object, with a valid object, right? The name Bob, but age is also a valid age. So I'm calling the constructor again, but with a valid default age, which is 21. So let's build this. And then let's go copy and paste the dynamic library. So let's see what happens here. So we come back with a valid object, but then the question is what happens here, because now this Bob is a valid object, but we know that an exception was thrown when we call the constructor. Even though we are coming back with a valid object, we are actually not handling the exception in C++ because we're not calling the exception clear. So what we expect to happen here is that if we don't handle the exception, even though we're coming back with a valid person, this line of code should not be executed, and we should immediately go out of this test1 method, go back to main, and then the exception is going to be thrown out of the main. So let's run this. So as you can see, Java exception occurred in C++, right? But then we came back with a new object, but doesn't matter because we didn't handle the exception. So JVM freaks out and it starts a stack unwinding and goes to the main, and then the exception is thrown out of the main. So age cannot be 0 or negative. Now if I go back to C++ and then actually clear the exception, right? Now when JVM goes back to Java, it doesn't freak out and it starts to continue normally. So let's build this. Let's copy and paste the dynamic library. And then let's go here and run it. Now I come back with a valid object which has the name Bob and age 21, right? This is how I'm handling this exception, and then this line of code bob.printinfo also is going to be executed. As you can see, there is no stack trace here. JVM didn't freak out because we told it that we handled the exception by asking it to clear the exception. And then as you can see, the default object was constructed. The name is Bob and age is 21 instead of -5, right? So what about printing the stack trace? This is again similar. We are handling the exception, but we want to also print the stack trace to see what exception was actually occurred. So we can also look at it. So we print the stack trace using this JVM exception describe. It doesn't do anything, it just prints the stack trace. So we build it, we copy and paste the dynamic library, and we can just execute this. As you can see, Java exception occurred in C++. Let's run it one more time. Yeah. So Java exception occurred in C++, and before that, before printing this to the console, we are printing the stack trace. That's why we see the stack trace in the beginning. But then we handle it, we came back, JVM didn't freak out, and it also executed this line of code. Print info, right? Name Bob, age 21. Okay. So this is how we can handle this exception, and then throwing new exception in C++ is also very easy. So let's say before even going into these, trying to construct an object, we check. So we say that if age is greater than 100, we want to throw so JVM throw new, right? And the class of that specific basically exception, and then the message, which is a constant pointer. So we can say age cannot be greater than 100, for example, right? So what is the J class? We need a J class. So J class basically illegal argument exception class is a JVM find class, right? And where is this illegal argument exception? Let's go back to Java. Illegal argument exception, let's open it up, and it's inside the package.java lang, right? So if I look at the constructor and look at go back to Java perspective and look at the bytecode, and then in the constructor, it's basically, if we go back to bytecode, it's Java lang illegal argument exception. Let's copy this, go back to C++ perspective, and here, so it's Java/lang illegal argument exception. That's the class path, and then we create it, and then we say that throw a new exception of this type, illegal argument exception, and the message here is that age cannot be greater than 100. So if you look at the signature, it gets a J class, the class that corresponds to a particular exception, which can be a user defined exception, right? An exception class that we created in Java, and const char pointer, this is a C style string, and we say that age cannot be greater than 100, right? So let's save this, let's build this, and then let's copy and paste the dynamic library. So what we did here, we handled the exception for the case when age is less than 0, but then if age was greater than 100, we are throwing a new Java exception in C++. So let's see if this works. Go back here, let's say 50, this should work fine. Yes, successfully created. What about 500? And as you can see, Java exception occurred in C++. Age cannot be greater than 100. So basically, as you can see, once this happens, we throw this exception. It doesn't immediately return, right? It just continues executing the other lines of code. So it goes and creates a person, but then checks if an exception occurs. It does, and then therefore it prints the stack trace. And then this message that Java exception occurred, and then it clears the exception and returns a default object, and then it executes the next line of code, right? So even if we throw an exception, the C++ code doesn't terminate, right? The JVM doesn't immediately return back from this line of code, right? It continues until it ends, right? Until the native method is complete, and then it returns back with the exception, right? But here obviously we are handling the exception. Let's say I don't clear it, then what happens? So let's say I don't clear this exception, this illegal argument exception. Let's copy and paste dynamic library. Let's go back here and run it again. Exception occurred in thread main, age cannot be greater than 100, right? Illegal argument exception, we print the stack trace, and then Java exception occurred, and then name Bob, age 21, right? So it come back, even though we threw a new exception, right? It goes ahead and then basically it comes back, and then nothing bad happened because we checked the exception here. So basically this line of code, bob.printinfo, still goes ahead and executes, right? We just threw an exception, but then in C++ we checked it, the exception was thrown, so we printed some stuff, and then we came back with a default object, right? So I hope you enjoyed this lecture and now have a very good understanding how to throw new exceptions, Java exceptions in C++, and more importantly, how to handle Java exceptions in C++. Please stay tuned, and I'll see you in the next one.